4.5 billion years ago, the planets were solidifying and undergoing a period of intense bombardment. The surface of Mars was no exception. 4 billion years ago, the surface was fractured and the planet was probably warmer and wetter. As time evolved, water filled these cracks, and the solutions may have resulted in the globules seen in the meteorite you're about to see. As the carbonate globules were growing, there was probably a presence of a microbiota. As the carbonates grew from the solutions and filled the fractures and voids, they began to entrain these organisms. We know this from the isotropic chemistry of the materials. Then, Mars went through a period of becoming colder and drier. We now know that during the period from 3.6 billion years ago up till 16 million years ago, a very large object struck the surface of Mars and knocked material from the surface, which then travelled through space for up to 16 million years until it was attracted by Earth's gravity, and about 13,000 years ago fell onto the Antarctic ice sheet, where it resided until discovered in 1996. A joint science foundation for the collection of meteorites, supported by NASA and the Smithsonian Institute, brought the sample back to the Johnson Space Center, where it was cleaned and processed. A closer look underneath the bladed surface, created as it came through the Earth's atmosphere, notes the areas of weathering and alteration. As we look closer at the spot magnified many times, thanks to Monica Grady from the British Museum, we can detect the carbonate globules with their black and white rims. These are 250 microns, or approximately 5 times the diameter of a human hair, and point to the fact that billions of years ago, life in some form did exist on Mars. The equipment used to ascertain the information on the meteorite is so sensitive that it's able only to view 1,000 molecules at a time. An infrared laser hits the sample, causing it to heat up and evaporate. This produces a plume of gas cloud. Then the ultraviolet laser excites some of the molecules that can absorb it, producing ions which are picked up by the detector. The process is repeated to produce a map of the sample. By detecting the arrival time of the ions, the weight of the molecule is measured, convincing scientists of the first organic molecules from Mars.